Good morning, students. I'm Yogadharani, working as Assistant Professor at Department of Computer Science and Engineering at SNS College of Technology. And today we are going to start a very important and interesting topic called historical context and motivation for deep learning. So before we go into the coding or mathematics, we must understand why deep learning came into existence and how it evolved. So this subject will help you understand technologies like face recognition, self-driving cars, voice assistance, and ChatGPT. Don't worry if you do not know anything about artificial intelligence or machine learning. I will explain everything from the basis. So next. So in today's session, I will follow a simple structure. First, we'll do a small recap. Then we will have an activity to help you think like a machine. After that, I'll explain the concept step by step. At the end of the session, we'll summarize what we have learned and check your understanding. So this structure is designed to that learning becomes easy and not stressful. Slide, let us start with a simple question. How do a human learns and why learn by seeing example? In the same way, deep learning allows learning from data. So deep learning is the type of machine learning that uses multi-layer networks. Those networks are inspired by human brains. Just like our brain has many neurons connected together, deep learning models have artificial neurons that are arranged in layers. So the main advantage of a deep learning is that it can be automatically learn patterns from large amount of data without a human manually telling it what it look for. The objective of the deep learning is understand evaluation of deep learning, know why deep networks become essential, and learn from the historical context and motivation through the breakthroughs. In next slide, the empathy part. Imagine how a small child learns to recognize a cat. Nobody gives rules like number of legs, size of tail, or shape of ears. The child simply sees many cats and learns automatically. Now imagine asking a computer to do the same task. Earlier, machine learning methods are not very good at this. They needed humans to manually tell the machines where features to use. This is what a big limitation. So this difficulty is the main reason why deep learning was developed. Let us clearly define the problem. Traditional method could not handle complex data like images, speech, and video. Also, humans had to manually design features, which was time consuming and error prone. For example, if we want to detect faces, engineers had to manually write rules for eyes, nose, and mouth. This approach does not work well in real world conditions. So the problem was clear. We needed machines that could learn features from themselves. Yes, understanding improves. This is exactly how deep learning model works. This activity helps you visualize learning instead of memorizing definitions. So the next one is ideate part. To solve the problems was discussed, researchers came up with a deep neural network. Deep neural network. These networks have many layers and can automatically learn features. Another major reason for success is the availability of big data and powerful GPUs. GPU stands for geographical processing units. And so faster computers means faster learning. So deep learning is successful not because of one reason, but because of multiple improvements happening together. Then working principle of this one is, let us look real world example. And this is the three hidden input raw material here. When you write a number, the computer sees only the pixel. The first layer detects simple edges. See here, edges. The next layer combines edges into shapes. Then finally recognize the digits. So this layer learning is called hierarchical feature extraction, and this is the heart of deep learning. Then technical depth of the deep learning is, at this stage, you don't need to master technical terms. You just need to be aware of them. So here this one is the activation function, as seen in the previous one. There are some points here are called as activation functions. This is whether the neurons should activate. And propagation is how the model learns from mistakes, and optimizers help the model learn faster. So there are the different architecture of different tasks. CNN stands for convolution neural network, and it's mainly used for images. Then RNN stands for recurrent neural network. It is mainly used for sequential data. And transformers for languages, it's mainly used in NLP, that is natural level language. And GAN stands for generative adversarial network. It's mainly used for image generation. And the next one is applications, futures, and here deep learning is not limited to computer science. It is mainly used for medicine, for disease detection, in finance, for fraud detection, and in biology for protein analysis. In future, the deep learning will power autonomous vehicles such as Tesla, that is self-driving car, then smart healthcare, and intelligent education system. This is why learning this subject is very important for your career. Then summary part, to summarize, deep learning evolved from early neural network models, and it can become powerful due to data of large data, faster computers, and better algorithms. Today it forms the backbone of modern AI. So this is the brief mind map of deep learning, its history, and how deep learning evolved as shown in this conclusion. In conclusion, this topic gives you a strength of foundation. In upcoming classes, I will slowly move into models and practical implementations. For now, focus on understanding concepts. I catch you in another video, that is a basic supervised learning in another video. Thank you all.